Let's see. Stream manager. Okay. It's working. Can change title real quick. All right, that works. Let me get my link. Okay. Not sure what to play. Sure. Wait, L, that's down. Wait, up, no. I know my alphabet. Damn it. Okay. Cool. So, got one viewer. It's fair enough. Good enough, I guess. Actually, no. No viewers in chat, apparently. Whatever. So I want to basically make a control flow graph, which means turning a span of instructions, that's loud, turning a span of instructions into a graph of blocks. So let me first check my dependencies real quick. Do I have rivers installed? No? Rivers. There you go. It's only 1.0 apparently. Huh. I should ask Washi to update that then. Okay. So that's working. Cool, so essentially, let's see, so it has an end type. So control flow block is basically a node in a graph. Let me see if I can get an image. Maybe that helps me think about it. Yeah. That's a really good image. Damn. Alright, so let's see, that seems like a C-like language, fine. Okay. So if you jump to something, you jump to the start of the block, that's pretty important to know. Yeah. I mean, whatever, I know how a control flow graph works, I guess. Alright. Okay, so basically, control flow graph contains essentially a list of instructions and a type of the block, right? So what did I call it again? Where did I put it actually? Ah, here. So it's an instruction slice, which is just a list of instructions, or like a section of a method, which can be edited as well. So let's see. It's an instruction slice. Let's call it slice. I could call it instructions actually, it would make more sense. Yeah. Let's see. And type equals type, and slice is slice. Let me rename this to instructions maybe. Okay. Oh, hold on. Okay, so there's an end type and an instruction. So the end type is basically what kind of control flow block is this. So like it could just be a fall through block. So if you look at our example, like 1 would be a normal fall through block, right? Because it goes from 1 to 2 at the end. And nothing happens when you put them back together. You have like an unconditional jump, which is like the end of 7. Actually no, that's a conditional jump because it checks like this while loop. You could say that at least. No, actually it's unconditional because it jumps to 2 and then 2 is an conditional jump, right? Then you have return, that's the end of a block. Now, there's more because there's also, right, thanks. Yes, that's less music. It's the official soundtrack. I can put on something else, but I just picked something because it's just music. So you have like your normal blocks, and then you also have, I guess, the block that leaves an exception handler block. So I guess leave, it would be leave S. But I'm not sure what to call it. Because like in IL you have the leave as instruction, which means you basically, yep, remove that real quick. Okay, let's see. So that's exit a protected region of code, right? I'll leave and leave as. So that's also a possible reason to end a block. So I just call that leave. Let's move that out of that. Code. Let's see. .NET instructions. No. Fuck's sake. Emits, apparently. Emits code leave. Okay, there we go. So that's the leave and leave S, which apparently is not a thing. Wait, there's leaves. What the fuck? Oh. No? Okay. Alright, so these are the 5 block types I know of. There could be more, in fact. I'm gonna check d4.dot as well. Let's see, GitHub. Because in d4.blocks there may be more, so I'll better check now. Just to make sure. Oh yeah, switch as well actually. Yeah, you can have switch. So you can have a switch instruction as well, which contains a list of possible things to jump to, which I'm not sure exactly what the opcode, the operand is, but whatever. Let's see, is there a block type? There's a scope block, try block, try handler block. Oh, control flow there. Let's see. Is there no type? That's the scope. No, that was the wrong one. So I don't think there's a list here of all block types. Block deobfuscator, guide control flow block deobfuscator. Yeah, that's just a deobfuscator. Like, it doesn't seem to actually make a graph, from what I can tell. Oh, it doesn't actually make. So it actually doesn't make a data flow graph. It just. Huh. Well, I don't think I'll find much in this without a lot of looking, so. Let me just real quick check this as well. Yeah, there seems to be a lot of like specific optimizations on the block. No. Yeah, I'm just gonna leave this then. Alright, so see, so there's two things I want to do today, or want to do eventually, which is making a control flow graph, which is this thing, and a data flow graph, which is like which instruction depends on which other instruction, which is useful for making like garbage cleaning, like when obfuscators add a bunch of math to stuff. I can't show an example immediately because the NSPI still doesn't work for me on Linux. But I can open a VM later. Actually, no, I can use Kindly Contact. Yeah. Then. Wait, no. Where did I put him? It's in here, right? No. There you go. I don't know which ones they are, so I hope this one doesn't crash my browser. Alright, we'll leave this running. But yeah, data flow graph is useful for. Oh, there you go. Yeah, like this is a trash obfuscator. Whatever. So basically, like they parse a number, add it to something, and I keep doing this. And you can basically optimize this entire thing to like a few instructions. Like eventually, what does this do? Like puts it in A1. Is A1 used anywhere? Here. Yeah, it's a parameter to the function. to whatever that function is. A block copy. Yeah, so all these things you can optimize, and that's what I want to do. num17, yeah. So that's what a data flow graph can do. The problem is for a data flow graph, if you mix it with control flow, you're gonna get a very broken graph, right? So if you do the data flow graph thing on either instruction level within a control flow block, so you know that in the list of instructions you're analyzing, there is no branch out or inwards, then you can safely do a data flow graph and like optimize that set of instructions. Or you can do data flow graph on the actual control flow blocks, which means that if you know, for instance, you have like this bad example, I think. Like if you look at this line, say that's one of your control flow graphs, like mid equals low plus I divided by 2. If you know how many, like if you know that this gives a constant number, then you can see the entire thing as a constant. And then if that is depended upon by another control flow block that accepts one number, and if that's a constant you can solve it, then it's kind of hard to explain, but basically if you can try to do it on a control flow level as well, control flow block. But anyway, for data flow graph, it's easier if you just have control flow already figured out. So I think I'm going to do control flow first. And I also already have a few things for them here, so that's convenient. So control flow, how do you start with that? Basically, you're just going to loop over a list of instructions, which in my case I will use an exception handler block, which is just like in this example it would be one big exception handler block because there's no exception handlers. But anyway, just a list of instructions, which would be a block. Does this inherit from that? No, apparently. It has one though, so it should be fine. So from that I will make control flow graph, because the only way to jump in or out of an exception handler block is either by just falling through, which I don't really care for, or jumping out with a leave s, which I handle here. So that should all be fine. So the control flow inside the block should be contained. Yeah, so I'm just gonna loop over this thing. Basically, for every instruction, I'm gonna check if it's a branch. I'm gonna put labels, quote unquote, on those instructions we're branching to, so I can split them up into blocks there. And then otherwise, if there are a control flow instruction like leave or switch or branches, I will jump as well. I will split them up as well. So I'm just gonna start doing that, I think. Let's see, control flow block. This makes a control flow block that's already split up because we're passing a type. So I'm gonna make sure that's clear with a comment. Creates. Let's see, control flow block from an already processed. No, not CLC. Oh, actually, that's paragraph. Type. There you go. Too lazy for these. Okay, so basically this one is already a control flow, like a single control flow block, right? Maybe I'll add that as a remark. I could optionally check for that here, but I'm too lazy. So that's the simplest way to make one. And then let's see. So I also want to make let's call it a big slice. This constructor will actually split up this thing. Actually, I can't do that as a constructor because this constructor makes one class, so that's not good. I would actually need to make a static factory method. Public static, let's see, ilist. I just make a normal list of control flow block, and then create. Actually, that would need to be a graph now that I think of it. Right. Because we're not making a list of control flow blocks linearly, because that's kind of useless, right? We want to make a graph, like an actual listing, this graph. So we can see like, oh, this 4, you get there from like 3 and it will always go to 2 again. If you look at it, apparently. Yeah, because if you look at this, like 4, it won't go to 5, 6, 7, it will immediately go to 2, right? So you can see that in this graph. So you can actually potentially use that to optimize stuff. If you know, like for instance, if this is always true, right, you can see 2 goes to 2, then goes to 3 and 8. But if you know it will never go to 3 because this is always true, or false rather, you can like remove everything, like you can move 3, 4, 5, 6 and 7. So that's what, so yeah, that's why a graph is way more useful than an actual list of control flow instructions. If you're just doing obfuscation, I think you could get away with just a list if you do control flow obfuscation, but I think it's easier to just have a graph. So let's see, can I do, so you have a graph, can you say a graph of an object? I'm not exactly sure, no. So you need to make your own graph. So I'll make a control flow graph, which means I won't be using this. I will actually make a class and make a, let's see, control flow graph. Also, I'm gonna make this internal, so people won't be an idiot and make it themselves with invalid data. So, graph. Let's see, do I need to do anything special? Because I want to make it to be, I want it to be a graph of a specific type. Like the nodes need to be. Guess you can't. Let's see. Let me double check. Is there a documentation? What's this sparse graph? I don't know what that is actually. Oh, not many edges. Okay. So you make a graph, you add nodes, you add edges. Okay. Graphs are directed, which makes sense. That's what we want, which means that every edge which is a line between these has one direction. In some cases, you want to have like it to be in 2 directions. Like say Facebook, they use a lot of graphs in the backend. We want 2 edges because they're like a friend is always a friend of the other person as well, right? So that would be an undirected graph. We want directed, so that's all good. Okay, now I'm not seeing anything about making your own graph. They always expect you to use their graph class and not like extend it. So instead of extending, I'm just gonna wait. Fuck. I'm just gonna make a private field or internal maybe. The graph, or just graph. Okay. On my constructor as well, which accepts a slice of instructions. And now I want to basically slice them up into like an actual graph, I think. Okay. Cool, so let's see, for the actual making of the graph, right? So basically I want to loop over every instruction. Whenever it's a branching instruction, I will cut off the group or the block where we're making as the previous instruction. So like cut off your tail, if you could say. Do we though? Hold on. So the thing is, if you're jumping to a graph, you jump at the start, right? Like if you look at 2, jump at the start of that. However, oh yeah, you don't always need to jump to the start. So actually, if it's branching, we don't need to. Only if it's like a while loop, which there's no instruction for, it's just branching. So if you have a while loop in IL, you would just have here like a branch to this. So we don't need to cut off our tail. So when we find a branching instruction, we just stop the block we have at that instruction. And we set the end type and stuff. And we add it to a list or something. Or we add it to our graph, I would say. Yeah. Right, and then the other case we can have is when we find an instruction that actually branches. So we need to split up the block it is in, right? So it starts at that instruction. So I think it's easier just do one pass and to like split up the instructions that stop a block, and then on the second pass actually do the other way around. I think that would be a lot easier. Otherwise, if you have a branch that's forward, we don't have a block for that yet, so we need to remember and stuff. So yeah, our first iteration will just stop a block like you had this while loop when it's a branching instruction. So that's the first thing. Now, do I immediately add it to the graph? I don't know. Can you do graph.create? No. And it's a directed graph, so I think that's true. Yes, because we have singular direction. Okay. Actually, do we need a graph? Because if you think about it, every control flow block, we can look at the end of it and see. Yeah, I would probably want a graph, whatever. Let's see. Okay, so we have a graph. Then, can I loop over him? Oh, come on, please tell me I can. Hold on. So I'm accepting an instruction slice, but that's not the thing I work with internally. I work with an internal instruction slice, which is implemented by this instruction slice and the actual method. And we actually want to take a method and both a slice, which is super annoying. So I'm gonna need to make 2 overloads for a constructor, because I need to accept both editable method body and instruction slice, because I can't accept this because that's internal type. Okay. Where's control flow block? I don't care. That's not what I need. Okay, so that needs to be instruction slice and editable method body, and this becomes internal. Okay, cool. That's actually not very clean now I think of it. Right. Let's do it differently. Okay, so that's internal. Okay. Alright. And then this becomes there you go. Instruction. There you go, that's the proper one. Super over-engineered actually, but alright. Cool. So that's proper. Now I can make this that again. Okay, cool. Back to this. So I think now I can actually loop over my instructions. Yes. What? Wait, what the fuck? Oh no. How do I get my instructions? Icons? added then. Okay. Wait, was it already implemented here? Oh yeah, cool. Wait, I need to in the... That's the wrong one. I need that in here. Alright. Because it's always useful to have a list of instructions for a slice. Okay, okay, can I finally get back to work then? Okay, finally. Can we now get back? Instructions dot get instructions. Alright, finally. So I don't think I need an index, so just for each. Alright, so we start. So we have an instruction slice, right? And we want to take instructions until, like, so we start here, we take them in there, and then we need to know where we started as well. So we need kind of like an index, like a current index, I guess, which I can get. Okay, so block start equals instruction. Then this naming is bad. Alright, so we have the start of the block, right? Is that an error or I don't know? Probably not. Can rename this twice. Okay. Cool. So at the start of the block we store our index, and then we check if this is check if it ends the block. Right? So which ones do? So we have the branching instructions, like branch, branch true, branch false, all those. Let's see. Most of them are here, but not all of them, because, you know. Actually, I think that's all of them. Probably is. Oh no, here's some as well. That's a lot of branching instructions. Fuck. A lot of these are aliases though, so that's okay. So I think the endlith has a thing for that. Let's see, I think we can use fancy C# features here. Var block end equals. Actually, I'm gonna change this to nullable block end type. So that will still be a struct because that's in which is a value type. Instruction match, right? No, match instruction. Man, I have no clue. No, switch instruction. Right, so switch. Yes, there we go. Okay, so if it's no. Crap. Wait, what is this? Instruction, yeah. Okay, you know what? No fancy features. We're just gonna do it ourselves. Instruction dot. Okay, there you go. Is there like is br? Yeah. Oh yes, one of the br instructions. So that's actually all of them then, I think. Nope, never mind. Okay, if br or wait, it's conditional. Oh no, because you also have unconditional branches, right? But that's a huge help. Holy fuck! Okay. Damn. Thanks, Skilled Onion. That's actually really useful. Okay. So if it's an unconditional, if it's conditional, let's see. Block end type. Alright, whoops. And this is conditional jump, right? Else if, come on. Is BR, I think, yep. Then end type is unconditional. Alright, that's already 2. Wait, was that it? No. Okay, that's just real quiet. Let's see, which other ones were there? I think switch and leave and return. The thing is, we return. No, return can be in the middle of a method as well. Now I think of it, yeah. So, instruction. Let's return. Else if direction is switch. There you go. Else nothing. Actually, yeah, let's do that, and it probably allow me to. No. Aw, come on. Whatever. Oh, this is allowed to switch. Hold on. Let's do some. I really want to use new C# features, so I'm gonna see if I can. Yeah. Come on, please work. Yeah, let's go. Well, almost. This isn't perfect. Yeah, I don't think I can improve this. No, I think it. Let's see. Switch. No. Wait, what's C# version am I on? 1.8. Can't I? Whatever. There. Okay, so. So if we have an end type now, right? So that means the instruction is the end of a block. So that would mean it's a return, it's a switch. I forgot leave, didn't I? Yes. Wait. Is leave. Leave. Did I forget any now? Fall through. Okay, that's good. So if there is an end type, which means we are at the end of a block, then the start of the block. Let me first like set this to false, no to true, because now we start a new block on the next iteration, if there is one. So now we make a new slice, or like a block rather. Var block equals new block. We pass in a slice. We make a new instruction slice, which means from the existing ones we make our own slice. The span. The start is the block start, and the end is the current. Big slice dot get in of the current instruction. Now, is that like inclusive? I don't even remember. Did I say that somewhere? I didn't. I think that's it's inclusive. See, start of the span, inclusive end of the span. What? Oh, yes. Hi, Jacob. And Thomas, the pro player. I am trying to make a deobfuscator for .NET. And right now I'm turning methods or parts of methods into a control flow graph. Okay, so that span has an inclusive end, just so I don't forget. Actually, be safe. Alright, so what's wrong here? Oh yeah, it needs the second parameter, which is the block type. Et. Now it's not null, and it knows it's not null because I have this, but because it's not a because it's not a nullable reference type, it's still actually a nullable of t, which means I need to do dot value here. Okay, so now we have a block. Cool. The thing is, if I add this to the graph, it will just be a node without any edges. And I kind of want a graph with edges, otherwise it's just a list, right? Like the edge, an edge is this thing, right? This line. For which obfuscator? Any obfuscator. It will work. It should work on any. Should work on any binary, not just ease. I'm actually not really that interested in ease, but eventually I want to make it a virtualizer, so yeah, ease as well. Obfuscator. So a node is this circle, and edge is the line, right? So just so you know. So how do I get the edges? Well, I think I can do that on my second pass, right? Because like in my second pass, I'll just loop over the lists I made. So actually, I don't need this yet. I can make that later, probably. And at first, just make a big list, I think. No, it's easier if it's already a graph, I think. Cool. Okay, so we have a block, and we add it to our graph. Wait, how do I add it? Nodes. Okay. Do I make a custom node? Music quieter, okay. OBS. Cool. Oh yeah, it's a little bit. Whatever. There. Tell me if this is better. It's kind of hard to tweak the music without hearing it myself. I mean, because I can turn it up and down, and it's not going to change for you, so. Or it shouldn't change for you. Better? Alright, cool. Okay, so nodes, I can make my own node class. I think that's easier. Let's see. Control flow node. What's actually inside a node? Now that I think of it. It contains this graph. This incoming edges. Oh, it contains incoming edges, outgoing, user data. Subgraph. What the fuck? Wait, what's a subgraph? I mean, it's a graph in a graph, I guess, but it contains just nodes. But probably, oh, subgraph. Oh my god. Okay, I'm just gonna ignore the subgraph because I have no clue what it is. Get edges, so that's union. Outgoing edges. So it's just all of the edges. And union is like, I assume, putting both of them together without any copies. On parent graph changed. Okay. I do need my own graph then, because this my own node, because it doesn't. Okay. And it needs a control flow block. Yes, block. And type string. Okay, So it adds it to the graph, and then it also sets its start of block to end, so that the next time we will make a new block when we keep looping. Let's see, this is inclusive because the first instruction is the start of the block, right? The second instruction is this. Yes. Now the thing is, we have block start. I actually can get rid of end of block because, like, here we do get instruction index, right? But we set this to true, so the next iteration we do this again, which is slow. So we're basically just repeating this, except this will be +1. So instead of using is start of block, I'm gonna remove this, change this to a check where this is -1, and we set it to start of the instruction, which should probably be 0 if we're working on a method, but if we accept an arbitrary slice, this can be anything else. Hold on. Block end. This, right? And then block start goes there. Okay, so what we do now instead is at start we have a block start of -1, which we detect. I can move this out as well. Would be cleaner, I think. So we can do big slice dot first. There. So now we immediately get the block start. So we get start of a block, which is the first instruction index. Then we loop here. We check if we're at the end every time. If we are, we make our span, make a slice, we put that in the graph, and then just set the block start to the new block. So I think that's a way better loop, actually. It's a lot clearer, at least to me. And it decreases this number, which is good. Even though it's already too high, whatever. I can abstract this, maybe. Should I? Ah, fine. Get block end type. Which returns a nullable one of those. Alright, and instead of doing that, I can just return every time. So I don't need the else's either. There. Cool. So that's a bit cleaner now, I guess. I can join this. Yeah. Okay, that's a lot cleaner. Now, our second iteration. Now we want to basically find our references. Use instruction references, split up blocks. So basically, if you have a branch, like say here, this would be a branch, it goes there, we need to split up this block, so it turns into 1 and 2. So find use instruction, well, operands, references, same thing, to split up blocks. And secondly, we also want to join the nodes in the graphs, because now they're just nodes without any connections, without any edges. We need to add those edges now. Cool. So to add an edge, we need to check the edge of the edge of a node or of a block, whatever. Now the thing is, we're gonna split up these blocks, right? And if you have an edge, that's between two nodes, but we're gonna be splitting up those nodes. So that means our what hotkeys? I think they are for, I'm not sure what the key binding thing the key binding config I am is key map. I'm using the IntelliJ one, so that's for all IntelliJ stuff, and I'm using Alt J select the next what's it called, next occurrence of my selection. Like if I want to change all these ifs, or like these ifs to else ifs, then there you go. Multi-line editing. Also, I often use Control W, but not that often actually. But it's pretty useful too. In the end, I just use Control to go back, and then Control Shift and an arrow key to select these things, so that's usually easier. And Control W closes the tab in my browser, so I'd rather not get used to pressing that. Okay, so we split up blocks, so I think we may need to do that in a third iteration. Or like, no, we need to do that in the second one, and then adding edges to the graph in the third one. However, that's a problem if you have fall-through ones when we split them up, so I think we should do some of them there. So I'm going to do add whoops, what the fuck? What is that, Control Shift backspace? Ah, holy fuck, didn't know you could do that. What is this? Huh. And add fall-through edges. Right, so, and then third iteration, add remaining edges, and those remaining edges are the block end types. Or block end types. Whatever. Right, so why do I do this? First of all, we need to split up a block, right? So first, 1 and 2 are actually together. And it could be that you have a jump that goes to the top of 1, right? Like say here you go, I don't know, back to 1. And this is actually one block. And then if you split this up, then like you will have 2 new nodes, and like where's the edge pointing to, right? You don't really know. So if you're splitting up edges while they're still, no, if you're splitting up nodes while there's still edges pointing to them, that's a bit dangerous. You need to really keep track of where your edges are going. So I'm just avoiding that problem by not adding edges yet when I'm splitting them up, except when I'm splitting them up with a fall-through edge, like splitting up these like 1 and 2, right? I will add this edge because that one just happens because you literally fall through. So that's one start point, one end point. I mean, every edge is one start, one end. I don't know, it's just whatever, just go with it. Like if you have a switch, you will have multiple outgoing and stuff, right? I won't have any loops, at least, which just fall through. That's what I want to say. So I won't need to worry about incoming edges being like, where do they go or something. Whatever. I can probably go without doing this in 3 ways, but whatever. Let's see. So use instruction references to split up blocks and add fall-through edges. So I have my graph. I have my nodes. I'm gonna go through all of them and split them up. Problem is you can't edit a collection when you're using a for loop. So I should probably get like this in a variable. I would actually like a copy of the node collection. Right, so I can... No, that's a... How do I do this? Because when I'm looping over the node collection, which is a collection, I can't modify it, I can't insert anything into it because I'm using a for loop over it. And I can't use like a normal index, right? Because that's... oops. That's not gonna work. There's no array accessor. Oh, there is string. But yeah, I can't use a for loop over a string. So I can't use this. I can't use a normal for loop. I need to use a for each. And I can't insert... Like if I split up a node, I'm basically creating an extra one, an extra node. So I need to add that to the node collection. Which means I'm editing the collection, so I can't do that. I could try to do it afterwards, so I could do like this, and then whenever I have a new node, I just add it to like some kind of queue here. Queue of nodes or something. What kind of node is this? CFN. Okay, yeah. So I could do this, right? Make a queue, and then here, empty the queue and add every node into the collection. So outside of the for each loop. That should be fine. The only problem is like when I'm looping here. So that's not fine actually, because if I'm looping here, I may have a branch into a node that's inside the queue. So I need to check for that. And I don't think I can have an edge to a node that's not yet inside the graph. So that's a problem. I can get around that problem by basically every time I split up a node, I just break out of the loop and I jump back here, right? I jump to this point and start the loop again. And I know I won't like split this up again because, you know, it's already split up and I don't need to worry about that specific branch anymore. That's a problem because that's like very slow on huge methods. That's I think quadratic, complexity. I don't know, I'm not a complexity expert, but basically it's gonna be super slow if your output gets bigger, or if your method gets bigger. So that's really bad. So that's one thing. I can also just have a collection of labels, I think. So I loop over every node, then every instruction inside the node, and add it to a collection of labels. Actually for that I don't even need to loop over the nodes, I can just loop over the slices actually. Over the instructions in the slice because I'm going over every instruction. So actually that's a good solution because then I don't need to loop over this, which means I can edit the nodes collection as much as I want. So that's actually, I mean I should have thought of that because it's just a second iteration over the instructions, so it's kind of a stupid, I don't know why I really have to think over it that much. So that's a good solution then. So we're looping over it again. Then I basically need to check if the operand of the instruction references another instruction. If it's like a block. Oh, actually. Now that I think of it, the only instructions that are going to jump are those at the end of a block. So I can speed these up by just branching instructions. By just taking the graph, taking all the nodes. What is that? C7. And then taking the last instruction of each node. Then I don't need to loop over every single instruction again, so that's faster as well. I can, I think it's best to just take both the instruction and the fall through, and the and like the type, the block end type, I guess. Right. So I take end dot. So I need to get the actual control flow block, right? Wait, can't I do it last? Ugh. Okay, you know what? We're gonna I instruction slice. I enumerable. That's gonna be a lot simpler. Yeah. That's gonna make future work a lot easier, and I can just make get instructions. No, remove get instructions because we're already instruction. Okay, cool. Where was I? Here. Okay. No, here. Yes. So that's the last instruction I need, and let's get the first one as well. Maybe. Yeah. There. This will be a problem if our instructions is empty, if we're working on an empty slice. So Right now I try to make empty flow node or block. Actually, that should be inside of this constructor. Slice, instructions, any. Try to make empty control flow block. Yes, there. So that shouldn't actually happen ever. Otherwise, this would crash, which is bad. I don't like crashing. Okay. Good. So we can take the last instruction and the type, which is also not in there yet. Can I do that? No. Public type. I think this can actually be internal, and then I don't need to do all these things. We'll see. Type, right, so now cast it to control flow node and select the last instruction and the type, and then we turn that into an array. We don't actually need to turn that into an array, but we're taking stuff from nodes. We do need to, because we're taking stuff from nodes. And if you don't get out everything before we start the for loop, and we add something to nodes, then it will crash. So that's why we need to do to array. You can also do to list, it's the same thing, basically. Okay, so we have our instruction. I'm gonna deconstruct this, because otherwise I'm gonna be confused. Alright, so let's see. Can't we? Okay, so we can't ever get a fall through one yet because we haven't made those. New valid state except no valid program. What does that even mean? Nothing. Okay. What exception do we throw? It's like window shopping. This is fun. UI format, deal on the found. No. Come on, there was a really good one for this. I forgot which one. Argument exception? No. It's like an invalid state, right? So invalid operation maybe? No, that's not right. Exception, whatever. Got fall through block before we actually added. Do you know any counter against instruction emulation? Yes, don't use .NET. You're basically asking me, how do I stop an attacker from acting like a computer? Which is impossible because your program needs to run on a computer. An emulator just emulates, well, a computer. What you can try to do is try to use features that typical instruction emulators don't have. Like for instance, like some obscure opcode. Like what would one be? Arg lists. Most of them don't have that implemented, I think. I wouldn't know actually. I don't even know what that's used for, so yeah. So that one for instance. Let's see, is there another one? CP-BLK, that's like a mem copy, I think. Maybe that's not implemented, right? So try to use that in your... Isn't there a not implemented? Yeah, but that... that's not the correct thing, because it's not that it's not implemented, it's that it's invalid in this context, actually. Anyway, if you're trying to stop people from using emulators, try to make it so their emulator doesn't implement an instruction you're using. Like JMP maybe. Right? Maybe they haven't implemented this, or init BLK, which is memset, I think. Alright, there was another one that was really uncommon. Like, I have no clue what log alloc is. Like, it's some kind of thing. I don't know, it's probably not used. Like, even as 2 bytes, right? So that says enough. Just pick some instructions that they probably haven't implemented and then use those. However, if your attacker is using a proper emulator, like, I don't know, .NET itself and a debugger, then you can't stop them. There, that's enough of that. So got a filter block before we actually added one. So that shouldn't ever happen. I'm just doing this because it shouldn't. Wait, argument out of range. No, okay. So unconditional jump, what does that mean? Actually, same for this conditional jump. They're basically the same in this regard. And I think the same for leave, because that also has an instruction operand. And then this doesn't do anything. So that just breaks, so that's also good. Right? Then this. See, that's why it's not implemented, right? Because I haven't implemented this yet. I will do so in the future, which is why it shows up in my to-do list, which is a bit too big. Lib. Is that control flow graph? Yep, there you go. Not implement exceptions, so I can see this is something I didn't do yet. So make .NET Obfuscator are useless if it's possible to emulate all. What the fuck? No, just use something that's probably not implemented by the emulator. Because what an emulator does is it looks at every instruction and does what a normal computer would do. So emulate them. So if there's something that no program ever uses, like that the compiler never emits, like, I don't know, ref any type, I have no clue what it is. Maybe in case this is never used, then emulators probably don't have it implemented. So you can try to use these in a valid context. And, you know, that would stop some emulators. Some of them, not all of them, because some of them are actually good and have everything implemented. Okay, so we have an unconditional jump, a conditional jump, and a leave. They all have operands that are instructions, which means they they like point to one thing. Yes, you need to use instructions that are not implemented in the emulator. You're welcome. Okay, so var operand equals operand. Now I need to do this because we're gonna reuse operand in this as well. Let's see. Oh yeah, that's true as well. I didn't think of that. Because you can just emulate push and pop without actually doing anything. Huh. I guess that's the way to stub instructions without crashing the entire emulator. Didn't think of that actually. Let's see. So leave operand. I need to make this an instruction, and I really hope that these are actual instructions because I haven't debugged like most of this. I'm just writing code without testing. I mean, I have a test thing, but it's just, does it not crash, I think. Right? Yeah, it does not crash and does it give the same thing. Arglist, something, and Bob. Oh, arglist, how many does it push? Does it push all of the arguments? Probably it doesn't, right? Returns the handle, so only one thing, okay. Last instruction, operand. Oh, what? Wait, is that actually? Oh my god. Wait, string. Is that like this? Runtime argument handle. No. You need an actual. Oh, so you need to pass like. Wait. Oh, it creates an actual array. What the fuck? I think that's incorrect, because it's just passing through the type. I think, want to meet those, whoa. If you want to meet those ref anything's mk ref. This is funny, the type hint seems to be incorrect. mk ref. Oops. Okay. I don't know. Oh, var arcs, okay. I see. Oh, wait, that's kind of cool actually. So I guess you can emit this with Roslyn. I don't know. If this instruction in str no. Okay. So I have our instruction now, so now we need to... I should make a local method for this. So I need to find the node it belongs to. And then split it up. It is possible that the node already has reference to it, but only... No, I can do this out of order actually. I can queue the edges maybe. Right, so right now I'm thinking like I need to add this to one of the nodes in the collection, right, in the graph. No, I mean I need to find, first of all I need to find the node this belongs to. So let's start with that at least. Target node equals graph. What is this? Nodes. Let's cast this. CFN. Where the node contains the instruction. Actually, that should be single, because there should not ever be a case where the instruction is there twice, unless it's an invalid method. The problem with single is that the exceptions are so trash, it's not even funny. Like it'll just say collection contains no things, whatever, without any context, which is just so bad. So I want to use single because it's simple. No contains instruction. Okay, so that's the target node. Then we need to split up this node, right? So we basically make a new node and resize the previous one, right? Now the node's gonna have edges, only incoming edges, which means edges that point to the start of the node, which means like control flow makes it so you go to the start of the node, which means we will resize the first part and make the second part ourselves. So What type is this control flow node? Oh, you gave me code. I want to try that code. Let's see. I think this compiles. Distros though. Break statement's missing. Oh yeah, makes sense. Make ref, it's not even highlighted. What can you do with a type? Okay, set manual ref int. Oh, that's cool. Wait, what can you do with a manual ref? Nothing. It's just a typed reference to something. So I assume that there's a heap allocation then. Because if you move this to like somewhere else, this will be out of scope and already it's on the stack, so it's gonna be a problem, right? Pass it to arglist. Yeah, it's got to be a heap allocation then, right? So it's just boxing. Well, it's not gonna box it because it's. Oh, that's cool. Obfuscator authors, take a note. This would be really easy to fix, I think, with you know what, I should probably use this, like optimize this in my, when I do data flow stuff. That's cool. I'm gonna write that down. Make sure people don't read what's on there. Okay. Let's see, deobfuscator notes. What you mean, please don't use it? I'm gonna fix it in my deobfuscator. The ref type. Oh, like that, yeah. I mean, isn't ref like super old anyway? Like, why would you use this to make ref and ref value? Like C#1 before it was actually, when it was just an ECMA standard? Yeah, var arg interrupt, but you can use ref, like you said, right? I don't know when ref was added, but it sounds super old. I'm drinking a bit, by the way, so. That's why I'm not typing. Oh, you can't use ref and var arg. Okay, cool. Anyway, let's get back to this. So we have our target node here. We're gonna split it up. Managed. Oh, so this typed reference is then on the heap, but it doesn't. You know what? I'm just gonna stop thinking about it, because otherwise I'm gonna stay here forever. Yeah, I'm safe probably. Okay, target node. I need to split this up. So I'm basically resizing the. Let's first see what's actually inside this. So we have a type. Not only the block, right? So we just resized the block itself. Yeah. And the block is in slice and then in type. Which means we need to allow this to be split up. So probably gonna call that split end or something. Public split end, and then an index. I think, or an instruction maybe. I think it's better to do it by instruction. Oops. Split after. Right. Hold on. So we have an instruction. We split it up, which means we split before, because it's the instructions we're jumping to, right? Split this this control flow block into two pieces by creating a scene before the parameter. Oops. So we create a scene before parameter and we'd return the second block. Right, so just to be sure, the instruction to the start of the second block, right? And then this is the second block. So the instruction that's the one you're calling this on will be the first block, which so basically this will shrink the first block. Let me just add a remark. This will shrink this block. Yeah, cool. So instruction blah blah blah. I'm using a long name so I don't forget it's before. Oops. Equals. No. That's gonna need to be a private set then. Wait a second. I don't have. Okay, I can't split this up because I'm having the public interface, so I need this to be internal. Actually, hold on. Where do I have errors right now? There as well. Really, having an interface for public and internal is such cancer. Okay, instruction is internal, which means that's this. Whoops. Okay. Okay. Good. Do I have any errors? Where is this used? There. We take a slice which returns an instruction slice which implements that interface. That's good. Whew. Okay, so now we can do this. It's internal. Get instruction index. That should probably be moved as well. I think. I don't know, should that be public? Get instruction index? No, I don't think span even is public, right? Yeah, so that shouldn't be public either. Okay. Just double check. Yeah, that's internal. Okay, cool. Split before index. So that's where you will start the first one. Add. Yeah. Whew. So So now I need to split this up, right? So the problem is I need to add the new slice to the parent of this slice, because the slicing thing works like as a tree, right? So you have your method body at the top, which will be sliced up by the blocks, this thing. So they will each have their own instruction slice, which is just a series of continuous block of instructions, right? And then this slice in turn can be split up as well. Why did I do that? I don't remember. I think I wanted to have like some kind of word checking, which wasn't needed actually, but whatever. I'm not changing it right now. We just have it, I guess. So this, we need to get the parent. Come on, why topmost? Oh, it has parent, doesn't it? Parents? Yes, okay. This. So it's already a slice, right? Because we're taking the slice somewhere. Oh god. Yeah, we do take slice here, so when we do this, it's always a slice. So actually I should accept instruction slice then, shouldn't I? Yeah. That makes stuff easier. Oop. There. I can rename that to slice as well. Okay, cool. So that's the slice. So a set of instructions. Okay. Slice. So that's the index, and then we get the parents. Okay, what's the problem? Was warned of this. I think by you, Radium. There. That's ugly. So now this should never be null because this is already an instruction slice whose parent should always be either another slice or a method body. You can't make an arbitrary slice. And even if you can, we should never be past one that doesn't have a parent. So I'm gonna throw here on parents is null. Tried to split a slice that did not have a parent. So that means we can't add the new slice to the parent. I'm gonna assert it here as well. Slice dot parents. Okay, that goes like this. And then parent is null. Okay. This is way too many brackets. Like, what the fuck, C#? Tried to create C flow block with no parents. Okay. Cool. So that should be an early warning at least, allowing me to debug. Okay, so we have the parent. We should now be... That's a reference type, noble reference type, so that should now be a proper reference type, which we know is not null. So basically, first we resize the first one. No, first we take... We make a new slice out of this one, and then add it to the parent, right? So new instruction, like we can't just take a slice of this one, right? So this dot take, wait, what the fuck? I'm pretty sure you should be able to take a slice. Oh, because it's like this thing, whatever. We can take a slice of this, but then it will be added to this slice and we need to remove it and add it to the parent, and that's just ugly. So instead, I'm gonna make a new slice. New instruction slice. What does that need? A parent, which is this parent, and then a span, which is a new span. The start of it will be split before index, which is the start of the new span, right? And then the end is end. No. Slice dot span dot end. There. What is wrong? That's not an instruction. Oh. There. Okay, so that's the new instruction slice, which is which we will return here. Right. However, we also need to add it to the parents. Oh god. Which I somehow need to add a slice back, which I don't have a method for. So I'm just gonna make one. Let's see. Oh, what the fuck? No. Internal void add slice manually. SIISI. Right. because the list of slices instruction slice has, I think, whatever, should be fine. Okay, that's slice manually. Is that already done somewhere? It's added here. Whatever. Oh, that's an instruction slice, okay. It's kind of funny to see my viewers like jump from like 3 to 10 to 3 to 8, now back to 3. Guess it's not very interesting. Whoa, what the fuck? Oh yeah, because I changed that, okay. Now that should be this. And I think that should be okay, yeah, it should be fine. Now I need to add it to something else. Wait, what's the error? Oh yeah, that's instruction slice, okay. Wait, I have C#8, I should be able to do a default. No, I can't because I don't have access to that thing, okay. Forward slices, add slice. I should really just make this a property so I can add it to this thing and have default implementations. Would be a lot simpler. Let's make that a to-do. I don't even need default implementation, you can also do extension methods. Or X method. There you go, close enough. Back to work. God, where was I actually? There's too many things. Not here. In the graph, I was looking at this and then... Oh yeah, I was here, I was splitting stuff up, right. Which is in here. Split end, okay, here we go. So, we have our second slice, we add it to the parent. Second slice, right? And then we resize our current one, which is slice pan end equals -1. So basically the previous one, so the instruction before the end. And I'm gonna make sure this is all fine as well. So the end index needs to already be greater than the new index, because that's the new one. Right, so that will be the new end index. And if that one's already equal or smaller, that means the previous slice, this length, it should be like 0, which is bad. Okay. And viewers are back to 7, like it's jumping a lot today. Let me real quick check Discord. Everything should be okay. Yeah. Okay. Cool. What's wrong here? Oh yeah, second slice. It's not a control flow block, meaning I need to make one. 'Cause I don't think, yeah. And end type is just a fall. Oh, wait a second. Oh yeah, I also need to edit the block type. Yeah. So that would be So that would be the previous one end type. Yeah, previous end type, and then equals fall through. Okay, so basically. So we take the instruction where it's like the index where it's split up, right? Then we make sure we have it a parent. We create a new slice, so the second part. So the second set of instructions now, and we add it to the parents. Then we resize this one. So that should all be fine, resizing it, because there's no other state that needs to be changed, I think. Then we create a second block. So we basically just make a control flow block with the end type. Then we reset the end type of this one to fall through, because now the first block will just fall through to the second one, and then return the second block. I don't really like how this is split up, but should be all good. Okay, so that's how we split up blocks. So now I want to do this here, which means we need to split up this node. Node split end with this instruction, which will also be passed through. Split end instruction. Right, return. So that should be a new control flow node. There. So that's basically just delegated to this one. Okay. Now do I need that thing? For new node equals this thing. But yeah, we need to add a new node to the graph as well. Oops. Okay. Now we can just inline. Yeah, should be clear enough. I mean, if I want, I can inline this as well, but people are gonna kill me for that. No, I'm just gonna keep this separate. It's clear. There's three things going on. First we get the target node, then we split it, and then we add it. So I'm just gonna make that three things. Let's take another drink. Okay, so I want to make this a method because I need to reuse it for the switch. Control, come on, Control Alt M. Yeah, local function. Well, okay, where do I need this? Doesn't really matter. At the beginning of this, yeah. Sure. Okay, so and it takes the instruction, which is the parameter. It does not return anything. And what it does is split node, I think. Okay. And that also needs to be part of it. Okay. That should never be reached. Maybe I should name it anyway. Let's see. So cool. Now what's the operand of a switch? I don't know about this. I think one way to find out is just new instruction. Nope, instruction. What parameters does it take? Please don't take an object. It takes an object, okay. Switch, change, no. It's probably like a... What operand does a switch instruction take? It's a list. Jump to one event values. So I assume if your switch is on 0, it will go to the first one, the second one, the third one. Wait, what's uint3? If any of the viewers know, you should tell me, because I don't know myself. Let me look for the ECMA thing. See my downloads maybe? Yes, ECMA 335. Open. Come on, okay. Let's see, so I need instruction. Three. Okay, and then we have switch. What was that part of? Base instruction, yeah, it should be in here then. Oh, there, switch. Okay, so what are the operands? Jump table, yeah, no shit. Oh, that's the amount. Oh, right, because inline it stores all the... Okay. So that's an N. It's to that target. Otherwise, it continues, so that's fault, that's basically the default branch, so that comes right after switch. Okay. If the target instruction has one more prefix codes, I don't care. Whoa, 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 whoa. Oh, okay, good. It can't go out of a block, that's good. Severely restricted and shall use leave instructions. Thank you very much. That makes stuff a lot easier. Correct CIL obeys the control flow transfer constraints listed above. Okay. Oh, hold on. Do I actually... Fuck, I can't relieve here. Okay, good. So essentially it's a jump table, and if the booked value is an integer under t1 or whatever it is, under this unsigned int, then okay. But how does the enlib do this? Let's see, GitHub oxe for the enlib. If we're lucky, it's on the README. Probably not. Nope. Okay, let's search for switch. Oh. No. Oh no, it's gonna... Fuck. It's gonna find all those. 72. Inline switch operand type. Oh. Ooh. Okay, hold on. Inline switch. Yeah. It's an I list of instruction targets. Beautiful. So that means I'm gonna real quick just throw an exception here, so I don't forget to update this later. That's the operand, and then if operand dot is I list of instruction boring switch node did not have switch table operand. Okay, cool. Let's capitalize this so it stops complaining. Cool. So for every instruction we basically do split node, right? Because none of them can be out of the block, which is good. God damn it. Please. Why is that in the same scope? What the f... This can literally only be used there. Why is that in the same scope? Okay, maybe there's a better name. Wat verdomme. Okay, just make these there. Good. Then for each instruction we split up, and then we also. So I think I already did it, right? Because hold on. I think. Okay, yeah, in here we already split up after a switch, which means that that's just falling through essentially on the default case, which means we already handled it here, right? So if you have a switch here, like get block end type, it's not null, like it's switch, then we just, yeah, we split it up, start a new block. So that's all fine. Why is that complaining? Oh, because it's fine, no comments. And break. Cool. Return doesn't do anything because it's basically like fall through, except you don't fall through, you just stop the method. So there's no outgoing edge here. Phew. So I need to fix this. The problem here is that we can call this on leave, which means the instruction it will go to could possibly be outside of the the big slice we're working on, right? So if I change this to or default, which means if it's not found, it's a null. So this could be null. If vn is null. Now I want to add a parameter, bool allow missing target equals false. If we don't allow it, we throw an exception. Right, so basically this is a branch that branched into something we don't allow. Like something that's, we try to branch into an instruction that's not inside the current slice, which means either someone unsafely edited the method and they didn't update reference, or it somehow jumps out of the slice, like it's for instance outside of an exception handler block, or they just took part of the exception handler block and it's just not like it doesn't work, right? So that's actually kind of a problem. Like that's sort of a valid way. Like it's not really invalid, I think, to just have an incomplete slice and pass that through, right? Like if you have a small section that you need to work on and you try to make a control flow graph of that and one of the instructions just jumps out, then you have an unresolved jump because you don't know where it jumps to, right? And throwing on that isn't really optimal, I think, because like I want to gracefully handle it and maybe like make it so the block just has an unresolved jump out of it. Maybe that's the nice thing to do, at least. To do unresolved branches should be okay. Okay, I think I'll do that for now. Why do you do this to me? I can handle this. Yeah. Okay, so that's what I do now, and if it's otherwise, so basically if we work with a leave, we just return, because we don't split up anything, right? Actually, I don't even need this, right? Because... yeah. what I can do is like have a parameter here, like throw on unresolved jump or something. That's something I can do. I don't know, it's not for now, I think. I just want to get this control flow stuff done. Let's see. Okay, cool. So now that works with leave. So let's see what we have now. If we have a fall through, we throw because that's an invalid state. I'm gonna move that down, this up. Then we have, so a return doesn't go anywhere, it just ends the method, so it doesn't need to have an outgoing edge eventually. That's all fine. Oh, actually I can do the edges in this loop, can't I? I'll do that later. So unconditional jumps. They have one jump target. One branch target. So split up node it branches to. Okay, and then we have here and the fall through. Yeah. Oh, that. Okay, so that's fine as well, and then we have this fall through, which doesn't do anything because it's invalid, and then otherwise if there's anything else, like if I add a block type and I don't handle it here, I'll just throw. Okay, whew. That should mean that once this loop is done, this iteration, we will have we're basically done splitting up. So now the last thing we need to do is actually the rest of the edges. That should be, yeah. I think all of those are easy to do because we have, like, what edges do we have? We've already done all the fall through ones because we added them ourselves when splitting up blocks. Switches are, like returns, we don't need anything. These jumps, for these we just like look at the branch target. For this one, it could be null. It's likely to be null actually. So that's all good. I don't know what to do when it's null. We'll see when we get there. And then with switch, we have a problem that we also need to fall through. We also need to have a branch for when it's the default case of the switch, because then it just falls through. Which is the same with the conditional jump, right? That also has one of those, like a fall through case when the condition isn't met and it just steps over the branch. Actually, it should be easy to find because we can use the spans as well. Just add one to the span and then find the instruction with that index. Okay. Cool. So now we just loop over everything again. This is really long though. I want to split it up. Oh well. Okay, so now we loop over every node. We won't be adding any nodes anymore, so it's fine to loop over it with a for each. So graph.nodes. Okay, so we can loop over every node, that's fine. And then we need to make all the edges besides the fall through ones because we've already done those, right? So node, actually I need to cast these as well because we know they're all control flow nodes, right? So type switch So if it's fall through, we just break, right? We don't do anything. I think we already made the outgoing edge. If it's an unconditional jump, I don't think, yeah, that's just, oh, I'm gonna do some magic. Okay, I'm gonna do this. No. No. We need to duplicate code, I think. Okay. Returns don't have outgoing edges. Okay, then we have leave and unconditional jump. They're basically the same, except leave can have an unresolved branch. But I think it's better to just handle that here as well for the future. If I ever end up fixing the to-do I made here. Was that here? I don't know. Oh, oops. Like this one. If I fix that, then I need to handle unresolved branches for both of those as well. For like unconditional jump and conditional jump. and switch as well. So we need to operand the branch target. Right, so let's see. Node, last instruction, operand. If do I really want to check everything again? Like, I'm gonna throw anyway, right? So I may as well just cast it, because that's easier. Okay, so that's the branch target, and then we need to find the block where that belongs to. So, first of all, if branch target is null, we don't do anything. Actually, that's to continue out of... Yeah, that's to continue out of the for each loop, right? I can do either break or continue. I'm gonna do break then. Okay, so now we know it's not null. We have the branch target. We need to find the block it goes to. Actually, no, that's not gonna be ever be true. Never mind, that's wrong. Okay, yeah, we need to find the block. So graph nodes cast that's singular defaults where the node, that's the control flow node, yeah. The first instruction equals the branch target, right? So this can be null. Target node equals this. If target node is null, then we continue or break or whatever. And if it's not null, we found or the thing to put our edge to, so we make graph dot edge. Yeah, edges add. So source and target. So that's our current node as a source node, and the target node is the end node. So now we have an edge. Now this edge doesn't have any information, right? So that's just a normal like jump thing. When we work with switches, it would be useful to add information to the edge to say like which case it is, or like which case it is, or which, or if it is the fall through one. That's something that's useful. But I think that's all I need for, sorry, that's all I need for unconditional and leave, right? So we have a branch target, find the node it belongs to. If there is none, we nope out, and then otherwise we add the edge. Cool. Now for a conditional jump, we do the same. We just do it for like the branch, we do that. Now it would be nice to know here what the actual condition is. So we can actually like optimize code if you find it. Like if we have, like I said before, a control flow, if you know that this is always true, we can like eliminate steps 3 to 7. So this entire part of the graph can go, right? Like 4 as well, I think. What's 4? Yeah, 3, 4, 5, 6, 7. You can eliminate all this. So it would just be 1, 2, 8, 9. But for that, to know that, we need to know what the condition is for while, which means we need that from the data flow graph actually. So, but we need to know which of the edges is the true case and which is the false case. So add info true case. Now we need the false case as well, which is just the fall true. So it's literally the one below. Which is just the instruction, the node of which the first instruction's index is 1 over the last one of this one. So just literally the block below. Let's see, node, is there a span we can get? So I don't think we get a span because everything that's in there. Actually, no, we can get a span from the block. It's not Easter, EC. What are you smoking? Yeah, we have a slice, and a slice is a span, which means we should be able to get a span. Okay. Thing is, I want to read only one because now it will give you a. Actually, that's internal. Should be fine. Yeah. Let's see. Public span. Span. Is block dot slice dot span. Okay, that's a lot of spans. I really should just make this public so I can get rid of all this stuff, but whatever. Okay, span. So target index is this +1, so literally the next instruction. We get that from graph nodes cast control flow node. I'm repeating this a lot. I should actually be able to just no, because that returns not enumerable. Never mind. That would enumerate it multiple times. So I could do single if I assume this is not the last one, but it could be the last one. So I need to do singular defaults. And which one where the node start equals the target index. Okay. Yes. And then if this is no break. No, actually this is a problem because I still need to continue to this one. So I actually need to invert this. Whoa, 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 whoa. Calm down. Did my stream die? Uh-oh. Please don't die. Okay, OBS is fine. Can someone say if my stream's dead? Just reloaded the dashboard and it seems to be okay. Maybe. Yeah, okay. Should be fine. Phew. So that's the false case, or the fell true one, right? I just there's no overload, I think. Okay. So we have this node. All right. I want to turn this into metas because they're like somewhat complicated. I mean, they're not complicated, but they're repeated, which is bad. Anyway. So that's that. Now the switch one. First of all, we have the fall through one, of course. And then for each of the conditional jumps, yeah. So I'm just gonna abstract this away. Let's see. Dude, I don't care where you do it. So case leave, that's this thing. For break. Beginning of this, yeah, sure. So the input is the node. Is this creates fall through, no, create branch edge. Okay. Yes. Okay. And the same thing happens here. That's just a branch edge, which is the through case, right? Yeah. Now for this, we basically do the same. Add info. Local, before switch, no type, no after. Wait. There. Yes. Wait, what? After... and this takes the node again, I think. Yes. No, create fall through edge. It's not a fall through edge really, but whatever. Well, it's a fall through edge, yeah. Whoa, where did that go? There. Huh. So that's node. Okay, cool. Okay, so that's the conditional jump. So for switch, we can also do fall through, because that's one of them. Fall through case. And then that's the branch edge, right? Maybe I should pass in an instruction. No, I'm just gonna copy it for whatever. Like, whoop. No. Yeah, I need to change this thing to an instruction. That is branch target. There. So that allows me to just loop over the switch parameters. Node dot last instruction operand. Cast it to an iList instruction. And create branch edge instruction. So that basically creates branches for each of the things. To do add info to edge, switch index. Okay, I think that's all of them. That should actually work. Oh, fuck. Node. There, okay. So let's see, which ones do we have? These are just function. What's this? Should be okay. Oop. Oop. So we're gonna add the other edges in this loop. If it's fall true, we already added it. Return doesn't have any. Leave and conditional jumps are just actual jumps straight to the other thing. Okay, and then unconditional jump, which is the same thing, an unconditional jump, or like an actual jump, and then the fall through. And then switch is a fall through for a default case. And then instruction, operand, instruction. Wait. Yeah, and then for each of the operands of the switch, we also create another branch edge thing. Okay, I think that's it, right? Now after this, I think I can just return the graph. And I think I'm actually done making the control flow graph, finally. This method is like 100 lines long, 120, yeah. I should split these up into functions, but I'm too lazy. Because I don't really want to split up the iterations, because like in each iteration of the function, because that means like the function itself doesn't have any meaning, it's just a section of logic that cannot be reused anyway. So I want to put them in the same method. But maybe these, no. I don't know. Let me take another drink real quick. Okay, now one feature that Rivers, the graphing library, has is that it can create dot files. So with the extension dot, like dots, right? Which is a graph which you can open in other tools. So I can actually make this graph if it works and then actually look at it. So that's what I want to do. Let me double check. These are all in use now, I think. That's in use. That's in use. Okay. So let's see, what did I change? So control flow block. That's a lot of color. Okay. Should be fine. Should be fine. Oh god. Could add rivers. How many to-dos did I leave in? A lot. Oh, did I? No, that's everything. Okay, instruction slice. So I added the get instructions thing. I moved it. Also, I want to make it implement get instructions. Implement this so I can remove get instructions, which is all good as well. Do that later, maybe. Add slice manually. Yep, sure. I don't know if I want to do this. Not sure yet. Add slice manually. Yep. And then span was updated for comments, and so I can change the indices. Why is that? That shouldn't be even internal because the span itself is already internal, right? So I don't need to change this. Okay, does it compile? That's also a good test. Yes, okay. Nice. So allow creating control flow graphs. Just gonna commit this for now so I don't forget anything. So I don't lose anything rather. Come on. Why you could be like that? Push. It's not pushing. SSH key invalid. What? Maybe I need, oops. Maybe I need to unlock my thing. Does it work now? Push. No? Yes? Yeah, okay, now it pushed. Good. Alright, so I want to make an actual graph. I'm gonna do something really hacky, I think. I'm just gonna make a real quick test method here. And I'm gonna make a graph for one of these. Oh, I don't like this. Let's make my own public static int blah blah blah. Let's see, so int x equals 0 while x is smaller than 12 if x modulo 2 equals 3, something like this. Switch x maybe case 3. Oh, is it gonna add multiple edges if... No, it's probably gonna optimize to say x minus 3 and then... No, but what will it... Not exactly sure what code it will generate. Okay, that should be a good example to work on, right? Let's see. So basically, it's just that's a branch, that's a branch, that's one, which means here at the end, and then we have a return at the end here as well. Okay, good. I don't have any leaf ones because that just makes stuff complicated. Okay, var body equals. How do I do this? Test targets. Oh, come on. Blah blah blah. Okay. how do I do this? And then I can, no, I can create a control flow graph of this. Oh, that reminds me. I can't create a control flow graph of a full method if there are, like, no, it should be fine to create one of a full method if it has exception handlers, I guess. So EMB and then, where is it? What did I make just now? Control flow graph. New of this. Okay. I need to sneeze. Wait, that's internal. Why is that internal? What? Because of that, yeah. Why can I use that? What the hell? Because it's a test method, maybe? That shouldn't be... Huh. Oh no, I'm using these. Okay, I'm stupid. Alright, so then here, I'm just gonna change this real quick. Okay, so I need to write this, right? Yes, I have a real voice. Not a fake one. Maybe I have a fake one, who knows? Wait, how do I write this out? Does this version not have it? Wait, hold on. Graph. Okay, where's the documentation? Inspecting nodes, searches, categorizing, generating, dominator, dot file. There you go. Okay, yoink. Thanks, I think. I mean, okay. Because this writes to my graph 2 dot dots. Okay. So if this works, run. That should write out the graph for this. No, why didn't it run? It ran everything except the one I wanted. Oh fuck. Wait, what? Oh, because what? Oh, because I tried to yeah, I make the groups here. Oh fuck. Why do I add a bunch of shit that's not useful? Exception handler groups. Why is that even a group? There. No. Yeah, I need to remove this thing, the blocking shit, because it's stupid. Wait, what am I running? Huh? Oh, okay. Let's see, run this. Come on. Come on. What is it? Okay, that's not normal. That shouldn't take forever. No, don't tell me I have an infinite loop somewhere. Come on. Okay, stop this. Okay, let's debug, and then I can break somewhere. Come on. Okay, so it's running right now. So where is the debug control? There is none. What the fuck is it doing? Okay, maybe I need to just whoop, whoop, like this. No? Oh, okay, here we go. Okay, so why is that null? Oh, because I'm making it still. Good. Okay, F8. F8. Okay, so it's definitely crashing there. Or getting stuck there. Okay. Am I blind? Oh, there, unit test, okay. Wait, that's still running. Why? How can that still run? Okay, so that's gonna debug this, and then it's probably in here it's giving a problem, not in here. So, oh, will you just fucking? Okay, what? Wait, that's in test, right? Yeah. Okay, now try it again. It's just embarrassing at this point. Okay, so that's what's step in again? Yeah, or just don't show me, fair enough. Oh, here. Oh, it's 7. I thought it was 9. What's 9? I guess F9 does not exist. Okay, so F7. 7? Probably that's the problem, yeah. Uh-oh. Is that already a problem? So that's the problem, okay. Which one is it? This is why I hate debugging. It's so slow, especially like this. Wait, why am I doing this in unit test? I can just use this thing. That's a lot easier. Okay. Okay, so it's in get instruction index of this instruction, which is some instruction. Who knows which one? Wait, what's the opcode? It's an op. So it's the first one. Oh, is it? It is a reference type, so it's unique. It should be unique, right? So get topmost parent and then get instruction index. Yeah, just this one. Whoa, hold on. Okay, what's parent? It's a slice. What's child? Well, it's the same thing, probably. Why? How the fuck does this happen? That the parent is the child. How did I manage this? Parent equals child, then we check again with parents. It's not null. So big slice, where does that come from? This. So somehow an exception handler block was created where the instructions are its own parents. Or it's up the thing, right? So actually, let me stop this. Start it again. Why can't I debug? Okay. So it means over here that should always also be the same. Come on. No? Okay. Oh, I need to step over F8. So slice. Where is it? Slice. The parent of the slice. That's the editable method body. So that's correct. Right? Oh, does that have a parent? No. Right? No, it doesn't have a parent. It shouldn't have a parent. Why do I overcomplicate shit like this? Null. Yeah, it's null. It's always null. So it's not this slice, that's the problem, even though that's the one I pass in. Somehow. Wait, okay, so that's the parent of this slice is the method body. And okay. This could actually be a problem. No. It should be fine. Okay, so it goes here, right? Creates a graph with these instructions. That's still the slice has the parent method body. So somehow, at this point, oh, hold on. First instruction. Yeah, okay. What? Big slice is instruction slice. The parent is still the method body. Okay. Step in this. 7. Right? Get topmost parent. Okay, so the child is instruction slice, whose parent is editable method body. Yeah. The parent returned editable method body. Oh my god, did I? I shouldn't be allowed to program. Alright, at least I know what goes wrong now. What? Ended on a branch. That's normal, right? No, it's not normal. Wait, how the fuck does that happen? Oh, it's an unresolved branch, yeah. Oh, because I didn't. Okay. First of all, this needs to be false. So no stop block type equals first of all. Okay, but that still got triggered somehow. So let's see what's the context there. I don't care about this one or this one. Okay, so we're allowing missing target, right? And we are doing this on br.s to this, which, oh, it's an off by 1 error, because that's the very last thing, I think. If you look at the slides, the length is like 56. No, never mind. Or I forget to add the last block. That's also possible. Because does it end on a return? I don't know if an IL body needs to end on a return, to be honest. I think it does. Especially if you... No, not if you have an... what's it called? A void return. Then I don't think you need to end on a return. I'm not sure. Span slices parent. Come on, just give me. Okay, that's the method body. That's the body. That's the instructions. Yeah, it ends on return. Whatever. I'm just stupid then. So it jumps to this. Whoa. IL1 jumps to this. Yeah, it jumps to. Okay. And the exception was then on a branch that's not in the current slice. It is in the current slice. The fuck are you talking about? So we need a node that contains this instruction, right? So that means I don't have that node. Nodes. So I have the return one, which is, wait, how come I only have 3? That means I am missing the last one, because I need 2 return ones, I think. Yeah, so it starts on knob, ends on 1. Yeah, so that's the first part. That's correct. This one is knob 3. Hold on. That is 1. I am skipping an instruction, I think. Because that last instruction is this, right? And if I look at the span, 1 and 2. It's from 1 until 0 until 1, which means length is 2. It's 2 instructions. That's correct. If you look here at the span, where's the span? There. It goes from, oh, that's 11. Well, okay, start index is still 2, and the first instruction is 3, which makes no sense, I think. Because it's 0 based, which means that is the third instruction, which is not, is that IL3? I don't even, no, that's 1. Man, it's tired, I should go to sleep. 0, 1, yeah. So end index is 1, last instruction is 1. So why the fuck is it start index 2 and it starts on 3? How does that happen? Okay, control flow node. Where's the control flow node? Right, and then it's get instructions first. Okay, it's get instructions of the slice, right? That should be correct, so... But it's correct for 1, but not for the other. Why is that? Block.slice. Oops, wrong one. Whatever. No, it's... If you look at the block, slice, instruction count is 2, span is 2 to 14. So it starts at 2. Why is that? I need sleep. I really do. I'm gonna stop once I get the dot file, I think. Okay, so nodes. So somehow that gives incorrect firsts. So as your method body, no instruction slice, yes. So if I do get instructions, that takes it from the parent using the span, so that should be correct. So get instructions here. So it skips that. So if it's 0, it skips 0. So that's like starting from that index, take the length. So why the fuck is that wrong? Because the span is correct. Is there a mismatch in span maybe? Like it's different at some place. First of all, am I actually adding the last block? Let's start with this. Maybe that fixes it. So for each instruction, if it's the end of a block, then do this. So that means if you're at the very last instruction, this will actually run because it ends on a return. However, if we have another thing, yeah, I think I should add an extra thing here. Like if we don't end on a return, we still want to add the block. So that's something I'm gonna add here. It's not gonna fix the problem, but it's something I should do. If block starts, is not big slice, get instructions, dot length, no count. So that would return, if there's 3 instructions, this would return 3, which means this. Oh no. Yeah, then like block end, that would be actually correct. So that's good. So if we didn't do this on the last iteration, then run this again, I think. No. I don't need this. The block end needs to be the amount of instructions. Yeah. So that goes here. It's a span, so it will be the last instruction, right? No, yeah, so this is inclusive. However, this will be exclusive, so I need to subtract 1. And this will be like, I don't know actually. None, unknown. Yeah. I need to add a new end type, I think. Not end on. When a slice falls through at the end. I can use a fall through for that though then. Yeah, let's just do fall through. That's better. Because then I'm sure the rest keeps working. Okay, whatever. There you go. So that won't fix it. But just in case. Please fix it. Didn't fix it, okay. I ended on a branch that was not in the current slice. Yeah. So basically I'm just not adding the slice because I skip an instruction somehow. So maybe this is just an off by 1 here. So block end is the instruction we end at, which is inclusive, right? So that's the instruction, the last instruction of the block, the one which caused the block to end. So then we make a span from the start, which is always at the start of the first instruction, so the actual index of the first instruction. And then here we just make the new start of the next instruction. So that's correct. Should be correct. Except it's wrong. So we start at 1, so we make that 2, right? So now our block start is 2, which is, yeah, that should be fine. So next time I'm there, we take a block start is 2, that is 14. Yeah, because the span is correct, right? Now this block, actually I can see it here, I think. So take slice returned, a slice, span 2, 14, blah blah blah. And the instructions, it doesn't show, but it should show in block end, I think. No, in block, yeah. No. There then. Why the fuck? So that's now 3, even though the span says it starts at 2. Why? Alright, let's look at that, why that happens. Graph, nodes, lasts. First instruction, right? Something like that. Oh, no, I need to cast it first. Because that's a control flow node. Dot. First instruction. Okay. Or I can just make this. That's a lot easier. Okay. Oh, fuck, no. Stop. Just run. Okay. I love how there's 7 people watching me debug something. Alright, 5, never mind. Okay, so that's the first one, right? First would be whoop whoop, F8. F8, yeah. Whoa. Oh, okay, whatever. Yeah, continue. So, that's the unconditional jump. First instruction. Wait, that's the wrong one. Okay, continue then. Okay, that's the conditional one. For which the first instruction is null for whatever reason. Okay, F7. Yes. So I already know what the slice is, so get instructions, I guess. So the span is still the same. That's still correct. Starts at 2, which is the third instruction. So it should be index. Oh, I just realized. IL03 doesn't mean the third instruction, it's the third like byte offset, isn't it? See, why does nobody tell me this? Okay, this is stupid. Okay, so whatever, that did work then. So I'm debugging the wrong thing, okay. The stream just died again. Let me reload Twitch. Check this. Yeah, it's still sending. Okay. So whatever. Let's put that back. So the problem was still here. So we get a branch that's not added somehow. So this would have fixed it then, I think. Because somehow it didn't. Is this incorrect maybe? So let's switch. Let's just take a look first at the method again and see, like, manually where the blocks should start and end. Okay, god damn it. What? Oh, because I'm in this method. Okay, I go up. Okay, so we have our parents, body, instructions. Okay, so this is one. That's the branch to further ahead. So that's an unconditional branch. Why the fuck is there an unconditional branch at the start? What the hell? What's the thing again? The method again? Oh, because it's a while loop. Okay, so it branches to 5, 6. This. So it loads arguments. Loads 12. Is it less? Store that, load it. Then we jump to 3. If that's true. Otherwise, we just exit. Right. So that's going to be a branch as well. Okay, so let's see. That's a branch. Check equals store. That's a branch at 14. So I think we do have this one. That one that worked. This one is one as well. Maybe it's just that the endlib doesn't correctly find the branch, right? So, do I still have that open? No. Get block type is conditional branch. So that finds all these, which should be all of them, right? Then isBR is one I check as well, which also checks all of them, and then same for leave. So it's not like they should be wrong. Okay, let's see if it's the switches one in there. Okay, there's no switch. So it's flattened the switch, I think. Oh well. Let me drink again while I think about this. Hey, Green. Hello there. Or Swaggy, whatever I need to call you here. Okay, so let's go back. Look at what branches we have, what blocks we have again. See, nodes. There's 3, which makes no sense. So somehow, like it did find this, right? So it went to 11, stopped there, and then somehow at the next one, started like at the end, and just didn't add the other ones. Somehow. Wait, this is in split node. Hold on. So we split node here, right? Because we get an instruction, which is this one. For whatever reason, we skipped all the other ones. Wait, last instruction. What the fuck? But that's the last instruction of this node, which there's only 3 of, which is not correct, because so the problem is in here. So somehow this returned null, maybe, or it just didn't add the blocks. So that just returned null because these did not get hit. I'm just gonna boop. Wait, that's the wrong one. There. All right, let's do this. Let's see how many times this gets hit. Also, I need this. No, I don't need this. So we hit it for 1, which jumps there. Okay. What's that? That's fine. Then it's hit for. Okay, you can just tell me what the instruction is. It's fine. BR falls at 17. Okay, so that's 2. That's 3, 4, 5. So it does return the thing. Right. And it works fine. Like it actually does all these. Okay. So I can remove these again. So that means it does return a null because these are not null. Okay. Which is here. If it's null, continue. Continue with the for each, yeah. So that means these are skipped. Yeah. So then, how many times does this get hit? Just to be sure. Let's see. Come on. Boop, boop, boop. Okay, 1, 2, 3, 4. Said I get hits plenty of times. It's like adding the node that doesn't work, maybe? If this is a rivers bug, I'm gonna kill Washi. Node. So I wanna know what the node is. So let's try again. Come on. Okay, so that's the unconditional jump at the end of 1. Is that correct? Yeah. At the end of 14, 26. He doesn't fucking add the nodes. How the fuck? Washi, why? Why do you ship buggy software? Like, why the fuck? What does this do? Come on. So that's a node. If it's null, or the parent graph is null, and the parent graph is null. Wait, so if the parent graph is not null, and it doesn't match, okay, that's good. If it already contains the key with the name... So the name of each node needs to be unique, otherwise it's overwritten. Alright, that was half an hour of debugging. Okay, so what do we need to do? Literally the only thing is just changing how this goes. Alright, so I'm just gonna add an instruction or something. Slice, span. Does that have a toString? No. If someone's near Washi right now, just give him a slap on the back of his head and tell him to be more clear about this. Oops. Starts. End. Okay, that should be fine. Oh, actually index, yeah. So now that should be unique. I clicked the wrong button again. Okay. It's unit tests. Run. Come on, just work. Is it in a loop again? Why is it looping? Oh, come on. I did fix the thing, right? Yeah, this is fixed. Why is that? Possible null dereference. No, it can't be a null dereference because I'm already checking for null there. Oh, fuck you. Why is this still running? Alright, debug. Is it hitting the breakpoint or something? It shouldn't hit breakpoints on normal run. Read the docs. It's not in... Look, where in the docs does it say unique name? Like, there's no mention of unique in here, right? If I look at the wiki... Oh, there is no wiki. Name. If I look for name... Get a node by its name, yeah. Oh. Nothing. It's not in the docs. God damn it. Why is this still pending? That's wrong. Stop. Okay, now that's how... Where is it hanging now? Okay, let's break there. Debug. Come on. Okay. Step in. Step in. Oh crap, yeah, of course it's gonna fuck. Well. Come on, just stop. Debug. Writer really needs better debugging for unit tests. Why is that? Okay, yeah, continue. Okay. Okay, let's see. New graph. Okay, let's just skip over these and see if, like, okay, so that's all fine. And we have this for each. Is that one fine? No, okay, that's where the error is. Okay. Stop running. Debug. Oh, my music stopped. Didn't notice. Okay, what's it doing? Yeah. Continue. 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 No, fuck. Okay, that's the wrong one again. Debug. So it's in here somewhere. Where is there a possible loop? Okay, let's see. How long is this? 14. There's 14 nodes in total. It's in split node? What the fuck? What's the loop in here? So it's not gonna be this, it's gonna be this then. Right? I should really debug more often. Instead of just writing code and hoping it works. Almost done. Okay, split end. Let's step in. Step in this. Get instruction index. What's the problem here? Get topmost. Really? Again? I hate this fucking method, the topmost parent thing. Come on. Okay, running. Whoop. Okay, so continue. Okay, so now get instruction index, yeah. Step in. No, in this. Step in this. Okay, so right now the parents is instruction slice, and the parent of the parents is huh? Okay, no, that should be fine, yeah. That's the entire thing. And then parent itself is this. Yeah, okay, so that's good, the first iteration, alright. F8. Cool. Now, that parent is the method body. Okay. Why is that still instruction slice? I changed it here. What the? Oops. Wait, parent is instruction slice again. But that parent. Really, just take my IDE away from me, please. End this suffering. How could I get this simple method so wrong? Like, what was this first? Parent equals child? What the fuck? Okay, now. Okay. Let's step over this. Now it should work, right? F8. Yeah, okay. Yes! Okay, now that works, good. Whoop. Right, step over. That works, cool. Continue. Okay, so now I'm trying to... That's literally a knob. How the fuck does this get called on knob? Leaf. It's not a leaf. It's not, huh? Oh wait, last instruction is 55 and 55 is an op, right? So I'm passing in the wrong instruction, I think. No, so I'm passing in the NOP, right? Okay. So this NOP, that's the target instruction. Right, so it's not anywhere. It's in this one though, right? No, this one. It's IL55. Wait, no. There. Just show me. Invalid operation. Wait, why is that an invalid operation? Wait, why are these spans different? That's already somewhat confusing. Am I splitting up? I think I split up a node and then didn't add it or something. Huh. That's not correct here. This should be used here. What the fuck? Respect. Oh, the name comes from this, yeah. So that name does not stay up to date. So that's kind of... Yeah, I've seen Vitil, it's pretty cool, but it's for native. And I'm not doing native reversing BTC fly. It's really cool though. I haven't looked at the code, but I really like the idea behind it. It's something I kind of want to... It would be cool if I could remake it for .NET. That would be really nice. But I don't know if I will. I'm planning on doing devirtualizers in the future, but I need to finish this first. So yeah, it's like lifting to some very simple instruction set, which can then, yeah, exactly. Because the problem with managed code is that it's a little bit more complicated in some ways, like you have references to other instructions and stuff. I'm not exactly sure. Actually, no, that should be fine because it's offsets, so yeah, it could be fine. It would be. I'm thinking of maybe porting that to .NET, but we'll see. Is this the start? Because it was wrong before. Yeah, I should never take the end into a new one, so this should be okay. All I can say is wink wink. Well, I would gladly have you make it for me, as long as I can use it in my project. Because you were working on something as well. I'm not sure if I can talk about what it is, but you were working on something interesting too. So, okay, let's see. So that's the knob. It's IL55. I don't know what index it is, but one of the nodes is just missing. No, not that. Oh, okay. Kinda related. Ooh. Well, I'm looking forward to it. Okay, I'm confused as to why this is here. Right? So you have this, which should only be one long. Yes, it is one long. What the fuck? Okay, that's not right. Yeah, let's add a check for that. exception? Alright. Invalid. What's argument exception? Yes, there you go. Argument exception. Okay, so now this will throw, which is good because it should never happen. Debug. So now I can see where that happens. Well, you should tell me about it in Discord later, Radium. Okay. Wait, why is this? Huh? Okay. So it's in split end that it's going wrong, right? So here in the setter of get index. Oh well, I would love to know about it. Could be useful to me. Okay, so the problem is in take. No, in this in split end, right? Split end. So I'm setting the end somewhere here. Split before index. So this is not inside a span. So that's from PI. It's greater than where is it? Slice span start. And I'm gonna do this apart. This. Start index. First slice would be empty. And here, so this happens if the split before is before the span. So split can't split. There you go. Should be good. I wonder if that will actually throw. I don't think it will. Like, if I just debug this now, I don't know if this will actually break the debugger. Probably will. I don't know. Oh, it will. Slowly. Where is my debug view? Wait, where's the actual debugger? Uh-oh. Oh, there you go. There, debugger, split end. Okay, so split before equals start index. That's a problem. So I'm not checking for that apparently. So So this instruction is actually the start instruction of this node, and that's the problem here. So that's the load string, I think. This target node, well, whatever, the target node, it's probably that, it's the start instruction. I should have checked for that. So like that, because of that, it's actually jumping to the start of the node, or of the block. So we try to split it up, but we can't because there's like a start, like otherwise we would have an empty node, so we would just have to add it. So basically, if instruction is not the first instruction, then you do this. Else, you just add the well, then you would just add the edge, but we're not adding edges here, so it's fine. Okay, let's try now. It ran. Okay. Okay. It actually worked. So now I just need to find the thing I made. It's in here. Yes! Found the dot file. Okay, so I can finally. So x dot, do I have x dot installed? No. Let's see. Fox dot x dot, yeah. Okay, almost. Okay, so x dot igraph to the dot. Come on. Fuck. It didn't work. Okay, what's the problem here? Syntax error on line 30. There is no line 30. Oh, it just ended. Oh, because I didn't. Okay, I see why. Yeah. Control flow graph. Yes, 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 yes. Using. Now it will work. Trust me. Okay. Come on. Yeah. So now it does have an end. Let's go. Okay, cool. It works. Oh my god, okay. Whew. I can go to sleep. Alright, so this is the actual control flow graph we'd made. It looks pretty cool. Why does this not go anywhere? That's wrong. Boys. Right. So this is confusing. This conditional jump here, right? It's not going anywhere. That seems wrong. Other than that, this also doesn't go anywhere. That's also bad. That should be going somewhere. Let's see. So we have an unconditional jump. That's like the while loop, right? Goes here. Maybe these arrows are just in the wrong direction. No. So 0 jumps to 48. Yeah. That's like... Where is it? Here. That's like the while loop, I think. Okay, and then there is a condition, like if x is greater than or something, then it should jump immediately to the return, I think. from what I remember. So I think my logic is wrong somewhere. Or it's Washi that screwed up, of course, you know. Could be possible. Probably not though. Why is there no fall through anywhere? Oh, because I didn't update the names, right, that's why. So I want to update the name somehow. Okay, does this set some... I don't know if that's a good idea, updating the name. So name, that's string name, this dot name. Huh. I don't think it's a good idea to update the name. But I want to. Wait, maybe I can do... Hold on, can I... No. Yeah, I can't update the name, crap. So basically the things here are wrong. Whoops. These things, like this one is going to be a fall through one. That's fall through, probably. Probably same for this. But we can't update the name because, you know, because we update the end type, but we can't update the name. Because of, you know, Washi API design. Let's see, so I have no clue what any of these do then. So I guess I'll have to debug. Maybe I should just give him a random name. I think that would be better. Maybe. No. I'll just remove the end type from it. Let's run that again. And it will just be numbers then. Come on. Come on. Yes, numbers, okay. Okay, so I want to break here somehow. Yes. Debug and look at what the actual graph looks like. Because this ain't good. I'm gonna create an issue, I think. Hehe. Wait. Did he actually update this? I'm gonna real quick just create the issue so I don't forget. An individual or of all of them at once. There you go. Washi, please fix. Okay, so let's ignore this breakpoints. Okay, double check this works. Okay, let's close this. Come on. Okay. Let's just do it here. Save your graph, your nodes. Okay. So if you look at the node 48, right? So that's damn it. Come on, make it smaller. I can't make it smaller. Why? Okay, whatever. There. Good, so we have 0, that's just nope and branch. Then we have 48, which is this. And it's on a branch through to IL3, so that's probably this one. Right, and then otherwise it goes there. So that's 54. 54. Oh, so this is actually a return then, probably. Same for these two. So actually my logic is correct, I think. No? No, there's nothing that returns here. Okay. So let's see. Let's look at 15. That's a fall through one. Oh, so fall through doesn't actually have an edge, right? Ends on a knob but doesn't do anything. So somehow I'm forgetting to do fall throughs. So how did this happen? Let's see. So and add fall through edges. Do I actually add those? No. From target nodes to new node. Okay, let's run it and see it magically update then. Oops. Come on, there. Now it should work then. Aha! So that's the two returns, right? If you look at our test method. We have return here and return here. Look, this is our branch. Whoops. So that's our happy path. It goes here. I mean, yeah, but I don't know if I can. I can't move it anyway. It's automatic layout. I think. What's this? That's zoom. Yeah. Anyway, that's the photo. I don't know why this is actually there. Like, what's 54? Oh, that's an unconditional jump then, I think. Let's see. So that should be an unconditional jump, you know? Come on. Running. Yes. Graph. Nodes. Results. Let's see. 54. That's an unconditional jump, exactly. So that just jumps straight to the end, yeah. So otherwise this would be a straight line, straight to this, which is return block. Okay, so otherwise we go here. We optionally do 15 according to some condition. I don't know what the condition is. Oh, that's this, yeah. So 15 is this block here. And we go back here, that's the switch, I guess. Which is just a series of jumps here. And then this last one can possibly return 0, I guess. Maybe. Not sure, what's 47? Oh, that go straight back here. Okay. So what's this return 0? Maybe it's 44. Yeah, that's 44. It's like a load 0 and then it jumps to the return, which is 57, which is only a return. No. Yes. No. What? Oh, you know, that puts 0 in constant 4 or local 4, 3, and then here it loads it again and returns it. Yeah. Okay, cool. So that actually works. Didn't expect that. Shit. I mean, I can't really show what the instructions are because I can't update the name. Washi, please fix. Cool, so this actually works. That's control flow working. Let me commit these bug fixes. Let's see, what should I commit? This. So not this, not this. I should commit this, I think. No, I can undo that. Yeah. This I should probably do. That one I should. That one I should. That one I should as well. Okay. Yes. No. Yes. No. Yes, okay, cool. Bug fixes to control flow. Or just bug fixes in general. Okay. It's almost it's actually 2:30, so I really need to go to sleep now. Because I need to get up at 10. Which is a pain. But it worked. Which is super cool. Actual control flow. So next I'm gonna do data flow, but that won't be today. Yeah. So I'm gonna end the stream now then. Let me git push. Come on. Yeah. Cool. Let me stop this too. Alright then, good night, I guess.